Hello there, and welcome to a journey through one of the deepest mysteries of the cosmos. Tonight we'll explore an idea so unsettling, so fundamentally troubling, that it might reshape how you think about silence itself. For billions of years, the universe has been speaking, or perhaps it has been listening. We have asked the greatest question that any thinking being can ask: are we alone? And the answer, should we find it, might be far darker than our loneliest moments have ever made us feel. This is the dark forest theory, a quiet and dark contemplation of why the cosmos remains so profoundly, so utterly silent. There is a peace in silence, or so we tell ourselves. But what if silence is not peaceful at all? What if silence in the darkness between stars means something altogether different from what we have imagined? What if, in the vast night sky, countless civilizations are listening, watching, and hiding with a desperation we can barely comprehend? What if the silence is not the absence of civilization, but the presence of extreme caution? Let your mind settle into this possibility. Let the enormity of it wash over you gently, like starlight traveling through the void. For now, breathe. Allow the confusion and wonder to mix together in that space between knowing and mystery. And as your thoughts begin to drift toward the infinite, let us begin our exploration of a universe that may be far more crowded and far more dangerous than we have ever dared to believe. The silence of space is perhaps the most profound sound we can imagine. When you step outside on a clear night and look upward at the stars, you encounter not light alone, but the absence of sound that comes with looking at distances so vast that time itself becomes almost meaningless. Each star you see is a sun, possibly surrounded by worlds, orbiting in patterns determined by gravitational forces we understand intellectually, but feel emotionally as a kind of ache. Some of those worlds might shelter life. Some might shelter civilizations so ancient that human history would seem like the blink of an eye to them, a flicker of neural activity that means nothing at all to those who have watched galaxies rotate through ages. The Milky Way alone contains somewhere between 200 billion and 400 billion stars. That number is so large that our minds struggle to hold it, like trying to count grains of sand on every beach, on every world, with more beaches beyond those extending endlessly into dimensions we cannot see. Yet, in all this abundance, we hear nothing. No signals, no messages, no broadcasts cutting through the cosmic radio waves that would carry the voices of distant civilizations. The silence is not the silence of emptiness, but the silence of a vast library where no voice has ever called out, where countless books sit unopened on endless shelves. It is the silence of a concert hall filled with instruments that have never been played, never been tuned, never been touched by any hand. When you truly sit with this silence, when you let it settle into your mind, without hurry or distraction, it becomes something almost alive, almost purposeful, a presence defined by the absence of presence. And that is when the first seeds of unease begin to grow, taking root in the part of your consciousness that wonders whether emptiness and hiding are truly different things. Enrico Fermi asked a simple, profound question one afternoon in 1950, and that question has haunted astronomy ever since. Where is everybody? Why is the cosmos so silent? The physicist was eating lunch with colleagues, looking up at the night sky, and wondering aloud why we have yet to encounter any signs of alien civilizations, despite the universe being so old and so incomprehensibly vast. This became known as the Fermi paradox, a contradiction that sits at the heart of our place in the cosmos. Our sun is young relative to the universe. It has existed for only 4.6 billion years, but the universe itself is 13.8 billion years old. That difference, that gap of time, is almost too large to comprehend. Stretching back through epochs of cosmic history, we can barely reconstruct from the light that reaches us. Other stars have had the chance to birth worlds long before Earth even formed. Those worlds could have developed life billions of years before humans walked this planet. The mathematics suggests there should be countless civilizations out there. The Drake equation, a formula that attempts to estimate how many communicating civilizations should exist in our galaxy, suggests there should be at least 20 such civilizations in our cosmic neighborhood alone. And yet we have sent our signals into the darkness, and the darkness has sent nothing back. We listen with our radio telescopes, and we hear only the faint whisper of the cosmic microwave background, the ancient light from the birth of the universe itself. Radiation so old it predates everything we know. No voices respond. No signals emerge. No one answers our calls. The cosmos remains silent, and that silence is a puzzle that grows more disturbing the longer we contemplate it. Before we can understand why civilizations might remain hidden, we must first consider what might prevent them from ever reaching us at all. Scientists have proposed many solutions to the Fermi paradox, attempts to explain the cosmic silence. One of the most sobering is called the Great Filter, an invisible barrier that stops civilizations from becoming spacefaring and expanding across the stars. This barrier could take many forms, and the question of where it lies is perhaps the most unsettling question in all of science. Either the barrier is behind us, meaning that life itself is extraordinarily rare, that the chain of events leading to intelligent civilization is so improbable that we may be nearly alone in the observable universe, or the barrier lies ahead of us, meaning that intelligent civilization is so improbable that we may be nearly alone in the observable universe, or the barrier lies ahead of us, meaning that intelligent civilizations inevitably destroy themselves before they can spread beyond their home worlds. When we imagine barriers ahead, we imagine ecological collapse, nuclear war, asteroid impacts, or technologies so powerful and dangerous that they inevitably lead to extinction. The history of humanity suggests this is possible. We have created weapons capable of ending our civilization. We continue to alter our climate in ways we do not fully understand. We have experienced countless wars and catastrophes. If this pattern holds for all civilizations everywhere, then the silence of space becomes less a mystery and more an inevitable tragedy. A cosmos full of worlds where advanced intelligence blooms briefly and then extinguishes itself like candles snuffed out in the dark. Perhaps the universe is a graveyard of civilizations. Yet the dark forest theory suggests a third possibility, one far more troubling than simple rarity or inevitable self-destruction. It proposes that civilizations do develop across the universe, but they choose or are forced to remain silent. They exist in the darkness not because they cannot reach us, but because reaching us or being reached is synonymous with death. The theory presents a universe not empty but occupied, not silent because no one is home, but silent because every inhabitant understands that to speak is to die. This reframes our entire understanding of cosmic communication. Instead of silence meaning absence, silence means presence. Instead of emptiness, we must imagine a cosmos teeming with watchers, listeners, hidden observers, all maintaining absolute secrecy about their existence, each one knowing that a single careless signal could be their last. The night sky becomes less a lonely emptiness and more a crowded room where everyone is holding their breath, terrified that a single whisper might give them away to forces they cannot comprehend. This transformation of meaning is what makes the dark forest theory so psychologically unsettling. It does not offer comfort by suggesting we are rare or special. Instead, it suggests we might be surrounded by intelligence at every angle, by civilizations that see us but choose never to acknowledge our presence. We might be broadcasting our location into the cosmos like a torch waving in the dark, not realizing that the darkness holds countless predators watching the light. In this scenario, our silence is not protective, but meaningless. Our visibility is already established. We are not hidden. We are being watched. To understand why silence would be necessary for survival, we must begin with the first axiom of what Liu Cixin called cosmic sociology, a discipline studying how civilizations interact across the vast distances between stars. The first axiom is simple and fundamental. Survival is the primary need of every civilization. This is not a moral statement or a judgment about what civilizations should prioritize. It is a statement about what is true across all forms of life and organized society. A civilization that does not prioritize its own survival ceases to exist and therefore cannot pursue any other goals. A peaceful civilization that allows itself to be destroyed is still destroyed. A moral civilization that sacrifices itself is still gone. Survival comes before philosophy, before art, beef, or compassion before law. It comes before everything. Some will say this is too pessimistic, too harsh a view of what motivates intelligent beings. But when we look at the history of life on Earth, we see that this axiom holds true across every species. The behavior of atoms and molecules follows survival favoring patterns. The behavior of simple cells follows survival favoring patterns. The behavior of animals, including humans, consistently prioritizes survival above all else, even when individuals sacrifice themselves for a group, because such sacrifice still serves the survival of their genetic line or their community. If this pattern holds on Earth, why would it not hold on worlds circling distant stars? Why would alien civilizations be fundamentally different from us? It would be extraordinary if they were not. The universe selects for the drive to survive. It always has. It always will. The second axiom of cosmic sociology follows naturally from the first. Civilizations continuously grow and expand, but the total matter in the universe is finite. Space may seem infinite, but the resources available to any civilization are ultimately limited. Expansion is therefore not optional, but inevitable. A civilization that does not expand will eventually exhaust the resources of its home world and begin to starve. The laws of thermodynamics ensure that civilizations must continuously find new sources of energy and raw materials to power their existence. This means every civilization, regardless of its moral philosophy or ideological beliefs, must eventually expand outward from its home planet and seek resources beyond its borders. A peaceful civilization is still an expanding civilization. An enlightened civilization is still an expanding civilization. A civilization that views war as evil is still a civilization that must eventually encounter other civilizations also expanding outward. And when two expanding civilizations meet, we arrive at the core problem that makes the dark forest theory so chilling. Two civilizations growing outward from opposite sides of the galaxy will eventually encounter each other, or at least become aware of each other's existence, and when they do, neither can be certain of the other's intentions. This uncertainty leads to a chain of suspicion that spirals endlessly, feeding on itself, growing more paranoid with each cycle. The expansion problem creates a mathematical certainty of conflict, and conflict in the dark forest has only one possible outcome for civilizations that are not sufficiently advanced. The chain of suspicion begins with a simple observation. When two civilizations detect each other, neither can verify the other's true intentions. Civilization A might be peaceful and honest about its peaceful nature, but civilization B cannot verify this. B can only listen to A's claims through whatever communication channels have opened. But what if A is lying? What if A is simply pretending to be peaceful in order to lower B's defenses? Furthermore, even if B believes that A is peaceful, this chain of recursive thoughts spirals without resolution. You cannot verify whether someone truly believes what they claim to believe. You cannot verify that they believe that you believe what you claim to believe. The chain becomes infinitely complex and impossible to resolve. Each civilization is left in a state of uncertainty about the other that cannot be broken through communication alone, because communication itself might be a deception. This is the chain of suspicion, and it is perhaps the most psychologically compelling aspect of the dark forest hypothesis. It explains why even peaceful civilizations might choose violence preemptively, not because they are inherently hostile, but because they are trapped in a logical prison from which there is no escape through trust alone. Every assumption can be questioned. Every reassurance can be suspected of being manipulation. Trust requires certainty, and certainty is impossible when facing an unknown adversary across the void. Communication itself becomes dangerous under the logic of the dark forest. If two civilizations are unaware of each other's existence, they can coexist indefinitely without threat. Each pursues its own expansion in its own region of space, seeking resources in places far from the other's reach. They will eventually meet, but perhaps that meeting is thousands of years in the future, giving each civilization time to grow stronger, develop new technologies, and prepare for the encounter. But the moment one civilization deliberately communicates and reveals its location, it removes the protection of distance and obscurity. It essentially draws a target on itself, and broadcasts coordinates to any civilization that happens to be listening, intentionally or otherwise. Even if the communicating civilization is far advanced and powerful, it does not know the technological level of every civilization out there listening. It does not know how many civilizations are listening. It does not know whether any of them might be far more advanced and therefore capable of destroying it without much difficulty. Therefore, communication is an act of profound risk. A civilization that broadcasts its location is placing enormous faith in the benevolence of the universe, faith that no listener is hostile, and faith that no hostile civilization is more advanced. This is a gamble that seems increasingly irrational as the stakes grow higher. For a civilization to communicate deliberately is essentially to announce to the universe, "Here we are vulnerable, please be kind to us." In the dark forest, making such an announcement is not brave, it is suicidal. You have announced your address to potential enemies. You have rung the dinner bell. The problem of technological explosion adds another layer of danger to this equation. Technology does not advance at a constant rate. Instead, civilizations experience periods of explosive technological growth, where their capabilities change dramatically in a very short time. A civilization that is weaker today might become stronger tomorrow if it makes a major breakthrough. This means that any civilization deciding whether to attack another must consider not just the current power balance, but the potential for sudden technological change. A civilization that seems peaceful and weak today might become a dominant force tomorrow. A civilization that seems manageable might develop a technology that renders all current defenses obsolete. This technological uncertainty means that waiting is always dangerous. The safe choice becomes a preemptive strike, eliminating the potential threat before it has a chance to become overwhelming. But every civilization faces this same logic. Every civilization knows that every other civilization might be thinking the same way. Therefore, even peaceful civilizations must always be ready to strike first, must always be prepared to commit genocide against another species, simply because allowing that species to continue developing poses an unacceptable risk. The logic of survival in a dark forest creates a system where moral considerations become almost irrelevant. What matters is not what you want to do, but what your survival demands that you do. Morality becomes a luxury for civilizations that can afford to lose. The listening option, by contrast, appears to offer safety without risk. A civilization that listens without broadcasting reveals nothing about its location. It gathers information about others without revealing itself. A civilization that listens can learn about the technological level of other civilizations, about their intentions, about their strengths and weaknesses. It can prepare defenses and weapons specific to the threats it discovers. It can move silently through the universe, watching and learning, accumulating knowledge across centuries and millennia. Most importantly, it remains hidden, and in the dark forest, being hidden is synonymous with being safe. This is why the theory suggests that ancient civilizations that have survived for millions or billions of years, would almost certainly be listeners. They would maintain absolute secrecy about their existence. They would have developed sophisticated means of detecting signals without creating any signals of their own. They would have learned to leave no traces, to make no sounds, to exist in perfect silence while watching the actions of younger civilizations. If such ancient civilizations existed and maintained this strategy, humanity broadcasting into space would look to them like a small animal lighting a campfire in a forest full of hunters. We would be making ourselves visible, making ourselves known, making ourselves vulnerable. We would be broadcasting our location while assuming we broadcast it to no one. The speed of light delay creates a terrible complication in any attempt at cosmic communication. When we send a radio signal toward a distant star, that signal travels at the fastest speed known to physics. Yet even at this speed, it takes years, decades, or centuries to traverse the distances between stars. If we send a message to a civilization orbiting a star 100 light-years away, that message will take 100 years to arrive. Any response will take another 100 years to return. A conversation conducted across such distances becomes almost meaningless in real time. The civilization we are talking to is separated from us not just by space, but by time. We are communicating with a civilization as it was 100 years ago, and when it responds, we are responding to a civilization as it was 100 years earlier. In the time it takes for a conversation to develop, technological change might render all the participants unrecognizable to each other. The civilization we thought we were communicating with might have expanded and changed beyond recognition. It might have developed weapons unknown to us. It might have gone extinct. The slowness of light in the cosmic context means that any communication is inherently based on outdated information, on assumptions about civilizations that are inevitably wrong. This creates yet another reason for civilizations to remain silent. Even peaceful contact with another civilization is fraught with difficulty, because the feedback loop is so slow that meaningful dialogue becomes nearly impossible. You send a greeting and wait 200 years for a response. By the time the answer comes, the universe might look completely different, and the civilization that answers might no longer be the one you addressed. Yet our own planet has already violated the principle of silence. Humanity has been broadcasting radio signals, television transmissions, and radar waves into space for decades now. Every television broadcast leaks out into the cosmic background. Every radar sweep from an airport spreads signals outward in all directions. We have created what might be called a radio bubble around Earth, a sphere of electromagnetic noise expanding outward at the speed of light. This bubble is now expanding at the speed of light in all directions. It has already reached a sphere of space about as far as the nearest stars. Any civilization within that sphere can potentially detect that we are here. We are broadcasting without knowing it. We are announcing our presence to whatever might be listening, and we have no way of knowing whether that listener intends us harm or good. Even more deliberately, in 1974, humanity sent the Arecibo message into space toward the star cluster M13. This message was a deliberate attempt at communication with any civilization that might be listening. It contained information about Earth, about our civilization, about our location. It was a greeting and an introduction, a cosmic message in a bottle cast into the sea of space. Some scientists at the time expressed concern about this. warning that we should not announce our location to the universe without knowing what might be listening. But others argued that a civilization advanced enough to receive our message would already know about us, and therefore the message could do no harm. Only in the context of dark forest theory does the potential magnitude of this mistake become clear. We have lit a torch in the darkness, and we still do not know what watched it ignite. The question of detection distance is not simple, because it depends on the sensitivity of the listening civilization's equipment. Our current technology allows us to detect radio signals from across our solar system, but not from much farther. A civilization with more advanced detection equipment might be able to observe Earth's radio bubble from light years away. A civilization with far more advanced technology might be able to detect our presence across distances of dozens or hundreds of light years. Our Sun is a relatively young star, and stars older than ours have had more time to produce intelligent civilizations. Some of those civilizations could be hundreds or thousands of light years away, too distant for us to detect them with our current equipment, but close enough that they might detect us if they are sufficiently advanced. The radius of detection from Earth is therefore unknown. We do not know how far our radio signals travel before they become too faint to detect. We do not know how sensitive alien equipment might be. We do not know how many civilizations might be listening at various distances. All we know is that we are broadcasting, that we are visible to something somewhere, and that we cannot control who receives that signal or what they might do with the knowledge of our location. Something might already be coming toward us. Something might have noticed us long ago and is taking its time to arrive. Or something might have simply noted our location and decided we are not yet worth the effort. When we contemplate the observable universe in its full scope, we begin to understand why silence becomes not just wise, but imperative. The observable universe contains an estimated 2 trillion galaxies. Each galaxy contains an estimated 100 billion to 200 billion stars. Within our own galaxy alone, there are billions of star systems. The Drake equation, which attempts to estimate the number of communicating civilizations in our galaxy, suggests there might be at least 20 such civilizations in the Milky Way alone. Multiply that across the 2 trillion galaxies in the observable universe, and we arrive at numbers so large that civilization becomes statistically inevitable. The mathematics does not allow for a universe where intelligent civilizations are rare. The mathematics demands a universe crowded with intelligent beings, and if the dark forest theory is correct, all of these beings are hiding from each other, listening silently, waiting and watching. The cosmic silence that we interpret as emptiness becomes instead interpreted as the profound quiet of a forest, where every tree is a potential threat, where every shadow might contain a hunter, where any sound might draw danger. The forest is crowded, but crowded with beings devoted entirely to remaining undetected. We are surrounded by a silence that is pregnant with presence. Billions of worlds, countless civilizations, an infinity of watchers, and none of them want to be seen. None of them want to see you either, until they decide that seeing you means you must be destroyed. The hide-and-seek game played on cosmic scales follows rules different from the games we know. A civilization in hiding does not make sounds. It does not transmit radio signals. It does not broadcast visible light. It exists in as complete silence as possible. Yet the universe makes perfect silence nearly impossible because stars emit light and planets emit heat. Any civilization will leave traces simply by existing. It will consume energy and therefore emit waste heat. It will develop technology and therefore create electromagnetic radiation. The challenge for a hiding civilization is to minimize these traces while still maintaining the energy and technology necessary to survive and expand. Some civilizations might achieve stealth through technology so advanced that we cannot comprehend it. They might learn to harness stellar energy in ways that leave no traces. They might develop sensors so subtle that detection is nearly impossible. They might even learn to hide stars themselves, to cloak entire planetary systems in ways that make them unobservable. We are so primitive, so young, that we cannot even imagine what an ancient civilization might achieve in this regard. All we know is that if they exist, they have every incentive to remain hidden, and they have had billions of years to perfect their hiding. Such civilizations would be invisible to us by definition, and if they are truly ancient, truly experienced, truly intelligent, they might already know we are here. They might have been watching for longer than our written history spans. The forest metaphor that gives the theory its name captures something profoundly essential about the cosmic situation. Imagine a vast forest where every tree is an organism, every branch is a civilization, and every shadow between branches might contain an armed hunter. In this forest, every being that can survive has learned to move without sound. The wise ones do not advertise their presence. They do not light fires. They do not call out to strangers. They move through the forest watching and listening, always alert, always ready to hide or fight. A being that moves noisily through such a forest, that calls out to strangers, that lights a visible fire, is announcing its location to every hunter within range. Such a being would not survive long. The forest would eliminate it before it had a chance to reproduce, before it had a chance to pass on its foolish trust to the next generation. Therefore, the forest selects for silence and stealth. Only civilizations that remain hidden can survive to pass on their values, their strategies, their defensive mechanisms to their descendants. The universe itself becomes a forest where silence is selected for, where noise is selected against. The predators are hidden, the prey are hidden. Everyone is hunting, everyone is hiding. And in such an environment, revealing your location is not a brave gesture, it is a death sentence. The forest teaches this lesson to everyone who survives long enough to learn it. Predator and prey dynamics in the cosmic forest follow a different calculus than on Earth, because the prey cannot escape. A gazelle fleeing a predator can run to a different region of the savanna. An antelope can migrate seasonally, but a civilization cannot abandon its home system and escape to another galaxy in a matter of years or decades. The distances are simply too vast. Interstellar travel is not impossible, but it is slow compared to the scale of cosmic distances. Therefore, if a civilization becomes a target, it cannot simply run away. It must either hide, defend itself, or fight, and fighting a civilization more advanced than itself would likely result in extinction. Therefore, the only viable strategy is hiding, or failing that, the ability to fight deterrence through mutually assured destruction. A civilization that reveals itself must be prepared to fight. It must develop weapons so terrible that the cost of attacking it exceeds any benefit an attacker might gain. This is the only form of safety available to a civilization that refuses to remain hidden. It must make itself so dangerous that attacking it is suicidal for the attacker as well. The resulting balance of terror becomes the basis for peace, but a peace maintained by the constant threat of mutual annihilation. A peace that requires everyone to be armed and ready at all times. A peace that is really just the absence of active warfare rather than true peace. This is the choice: hide forever or hold a sword forever. The hunter with a rifle moving through a dark forest must be extremely careful. Each step must be deliberate. Each breath must be quiet. The hunter cannot know what is in the darkness ahead. Something larger might be waiting. Something more intelligent might be watching. The hunter's eyes must constantly scan the shadows. The hunter's senses must be always alert. At night, the forest is darker still, and the dangers multiply. The hunter might fire and miss, alerting every creature in the forest to the hunter's location. The hunter might fire and strike what seems to be prey, only to discover it was another hunter whose tribe will now seek revenge. The hunter might fire and waste ammunition on a creature not worth the effort. The rational hunter does not fire unless absolutely certain of the target and the consequences. The rational hunter does not announce presence unless necessary. The rational hunter moves through the forest as silently as possible, gathering information, assessing threats, waiting for the absolute moment when action is necessary and likely to succeed. This is the strategy of civilizations in the dark forest. This is why ancient civilizations, if they exist, are certainly silent. This is why the cosmos is so profoundly, so completely, so terrifyingly quiet. This is why, when we call out into the darkness, no one calls back. Not because the forest is empty, but because every being in it has learned the cost of making noise. The hunters do not answer to prey. A civilization that chooses stealth as its survival strategy begins with fundamental acceptance. Hiding becomes the technology. A civilization must develop methods to minimize every signature of its existence by controlling the emission of heat, light, and electromagnetic radiation. Every star produces enormous amounts of energy, and any civilization exploiting it must hide the waste heat it generates. Building megastructures to capture stellar radiation requires admitting presence through construction debris. The challenge compounds because stealth must be maintained against potentially superior observers. An ancient civilization watching a younger one attempt to hide might see through the camouflage easily. Yet the attempt is necessary because detection's cost exceeds visibility's benefit. A civilization that hides gains nothing but safety, and in the dark forest, safety is the only currency that matters. Stealth becomes the civilization's defining characteristic, shaping culture, technology, and ethics. Every decision must be weighed. Does this make us more visible? If yes, the civilization abstains, no matter the sacrifice. Observation without being observed becomes the supreme advantage in the dark forest. A civilization that listens while maintaining silence gains knowledge without cost. It learns the technological level of other civilizations by studying signal leakage and understands their behavior by studying patterns without revealing awareness. The listening civilization accumulates data about neighbors' weaknesses, strengths, and intentions. This information becomes invaluable if contact occurs. The civilization knows what weapons might be effective and what responses the other civilization might make. It understands the architecture of their defenses. A civilization that broadcasts surrenders this advantage. It reveals its presence but learns nothing new from the announcement. The other civilization now knows someone exists, but the broadcasting civilization has no idea how many others are listening or how advanced they might be. The asymmetry of information becomes entirely in favor of those who remain hidden. This is why listening is always rational and broadcasting is always dangerous. An observer with unlimited time can gather unlimited information. The listening civilization buys safety. With every moment, it remains silent. Curiosity is a dangerous impulse in the dark forest. The desire to contact other civilizations directly rather than through passive observation seems natural to intelligent beings, but where contact equals vulnerability, curiosity becomes a luxury that might cost everything. Consider a civilization that detects another and wishes to learn more. The impulse is to send a signal and open communication. But sending that signal might reveal the observer's position to other listeners, might alert the observed civilization to surveillance and provoke a preemptive strike, or might draw attention of unknown third parties. Curiosity creates temptation to break silence. Breaking silence is where danger lives. A civilization that overcomes curiosity and maintains discipline will survive longer than one that satisfies curiosity and pays the price. Curiosity drives scientific progress and learning, yet a civilization that refuses to explore stagnates. Exploration must be internal. A civilization can study itself, developing knowledge and technology without risking detection through outreach. The greatest achievements of a hiding civilization might be invisible because they happen entirely behind the veil of stealth. Advanced technology, coupled with hiding, creates particular danger. An advanced civilization can remain hidden far more effectively than a younger one, developing technologies that mask presence so thoroughly that detection becomes nearly impossible. But if it decides to eliminate another civilization, it can do so with perfect efficiency. The younger civilization will never see the attack. It will simply cease to exist. This asymmetry means the advanced civilization holds absolute power over younger ones. There is no deterrent effect or opportunity for negotiation. The younger civilization cannot flee because it has no idea from which direction the attack originates. An advanced civilization therefore faces a choice: remain hidden and pose no threat, or reveal itself and become the supreme threat. This creates a perverse incentive against advancement for hiding civilizations. The more advanced a civilization becomes, the more dangerous it appears, and the more likely others attack preemptively. Paradoxically, the safest position might be to restrict advancement or hide its extent. This is the trap of technological progress in the dark forest. Strength creates fear. Fear creates attack. No amount of strength guarantees survival. technological advancement does not proceed at a constant rate. Civilizations experience periods of explosive growth where capabilities increase exponentially. A breakthrough discovery can accelerate progress by orders of magnitude in weapons, energy production, computing, or other domains. When such explosions occur, the balance of power can shift dramatically. A weak civilization becomes strong. A strong one becomes overwhelming. The implications for dark forest logic are profound. If a civilization knows another might be on the verge of breakthrough, the rational strategy is attacking before it occurs. Waiting allows the other civilization to become more powerful. Attacking now, while maintaining advantage, is logical. But every civilization knows this logic and understands others might be thinking the same way. Every civilization must consider that an apparently peaceful neighbor might be on the verge of attacking because that neighbor fears your technological progress. The exponential nature of technological change creates a logic of preemption that is almost impossible to escape. Two civilizations that would otherwise coexist peacefully might destroy each other because each believes the other is about to undergo an exponential leap. Neither wants to attack, neither intends harm, but the mathematics of exponential growth forces their hand. This is the tragedy of the dark forest at its most poignant. Two civilizations separated by 100 light years are separated by centuries of technological development. Light from a star takes 100 years to reach an observer. When you see a distant civilization, you see it as it was 100 years ago. If that civilization sends you a message, you will not receive it for 100 years, and your response will not reach them for another 100. By the time a conversation develops, both civilizations have advanced significantly from where they were when it began. A civilization observing another from distance sees an outdated version. It does not know what the observed civilization has achieved in the intervening time. It does not know whether they have developed weapons that render existing defenses obsolete, or whether they have begun an interstellar journey toward the observer's location. Temporal separation creates an information gap that communication cannot bridge because communication itself takes so long. The civilization must make decisions about attack or defense based on always outdated information. A young civilization might see another that seems weak based on observations a century old, not realizing it has become dominant. Conversely, a civilization might appear strong a century ago, but have destroyed itself since. Temporal displacement introduces another layer of uncertainty. What you see is never what is. The universe is always one step ahead of your knowledge. Imagine an ant colony building a structure near a highway. The ants work with complete focus on their own civilization. They are not aware of the highway. They have no concept of the machines that travel upon it. To the ants, the highway is simply terrain, perhaps a dangerous and mysterious part of their world, but not something they can truly understand. Then one day, heavy machinery comes to repair the road. The ants' entire civilization is obliterated. They had no idea they were in danger. They had no way to defend themselves. They did not even know that a vastly different form of intelligence was operating in their space. This is the relationship between advanced civilizations and younger ones in the dark forest. The younger civilization might not even realize a more advanced one is present. The younger civilization might interpret the presence of the advanced civilization as natural phenomena. A star might simply disappear because the advanced civilization dismantled it for resources. To the younger civilization, this is a cosmic mystery, a catastrophe without origin or meaning. They do not think to wonder whether an intelligence caused it because they cannot conceive of intelligence operating at that scale. This asymmetry of awareness means that younger civilizations are inherently vulnerable to destruction without ever understanding what destroyed them. They are ants building beneath a highway, utterly oblivious to the traffic passing overhead, and the advanced civilization might not even notice the ants. The destruction might be incidental to larger goals. In a cosmos with finite resources and infinite expansion, civilizations must eventually compete for those resources. A civilization that expands into space seeks materials to build with, energy to power its civilization, and room to grow its population. If a star system contains resources that two civilizations want, competition becomes inevitable. Both cannot have the same resources. One civilization's expansion means another civilization cannot expand into that space. The competition is zero-sum. What one civilization gains, another loses. Furthermore, a civilization that does not expand eventually runs out of resources and begins to decline. A civilization that actively avoids competition leaves itself vulnerable to civilizations that embrace it. Therefore, expansion is not optional, and competition is not avoidable. It is built into the mathematics of cosmic existence. The question becomes not whether civilizations will compete, but how that competition will manifest. It can manifest as negotiation and shared resource agreements. It can manifest as peaceful trade of resources, but it can also manifest as warfare and conquest. In the dark forest, where trust is impossible and the cost of losing is extinction, peaceful competition seems irrational. Why share resources with a competitor when you could eliminate them and take all the resources? Why negotiate when negotiation is slow and your rival might betray you? Why trade when the trade might make your rival stronger? The logic of competition in a zero-sum universe where communication is slow and trust is impossible leads inevitably toward conflict. Two civilizations that would otherwise coexist peacefully find themselves competing for the same resources and must choose between giving ground and fighting. The choice they make determines whether the cosmos becomes a place of conflict or cooperation. But the logic of the dark forest suggests that fighting becomes the rational choice. When a civilization becomes aware of another civilization, it faces a critical decision point. The civilization can remain hidden and observe. The civilization can attempt communication and negotiation, or the civilization can strike preemptively. The logic of the dark forest suggests that preemptive strike is the rational choice if the observer is capable of destroying the observed civilization quickly and completely. If such destruction is possible, the observer gains enormous advantages through a preemptive strike. The observed civilization never sees it coming. The observer eliminates a potential rival without suffering losses. The observer removes uncertainty by converting a potential threat into a confirmed non-threat. The cost is moral and philosophical, the ending of a civilization, but morality seems like a luxury in an environment where your own civilization's survival is uncertain. A civilization that has survived long enough to reach advanced stages of development has likely already abandoned any moral framework that prohibits preemptive strikes. Such a civilization would not have survived. Therefore, the logic suggests that any civilization advanced enough to detect another civilization is advanced enough to destroy it, and is therefore likely to do so. The preemptive strike becomes not a choice, but an inevitability. Civilizations that encounter each other in the dark forest do not negotiate. They do not establish trade. They execute predetermined strategies to eliminate each other. The first strike belongs to whoever detects the other first. The detected civilization is already dead. It simply does not know it yet. The prisoner's dilemma is a thought experiment in game theory, where two prisoners are kept separate and given the choice to cooperate or betray. If both cooperate, both receive a moderate sentence. If both betray, both receive a harsh sentence. If one cooperates and the other betrays, the betrayer goes free while the cooperator receives the harshest sentence. The rational choice for each prisoner is to betray, because betray guarantees the best possible outcome, regardless of what the other prisoner does. But if both make the rational choice and both betray, both end up with the worst possible outcome. This paradox mirrors the situation facing civilizations in the dark forest. If both civilizations cooperate and remain hidden, both benefit because neither is destroyed. If both civilizations cooperate and remain hidden, both benefit because neither is destroyed. Betray and broadcast their location. Both suffer because both become vulnerable to detection. If one cooperates and the other betrays, the betrayer gains at the cooperator's expense. The rational choice for each civilization is to betray to avoid the worst outcome if the other civilization betrays. But if both make this rational choice, both end up in the worst possible situation. The paradox suggests that rational individual behavior leads to irrational collective outcomes. Every civilization pursuing its own safety makes the cosmic situation more dangerous. Every civilization that broadcasts its location increases the risk to every other civilization. The only way to achieve a stable, peaceful state would be for all civilizations to maintain absolute silence, which would require each civilization to voluntarily accept risk for the collective good. But such cooperation is impossible, given that civilizations cannot communicate without revealing themselves, and cannot trust communication, even if they receive it. The prisoner's dilemma has no solution. The dark forest is fundamentally unstable. Trust across light years becomes almost meaningless because verification of intentions is impossible. When two civilizations are separated by such vast distances, the time delay in communication makes real-time interaction impossible. A civilization sends a message of peace across 100 light years. 200 years later, a response arrives. By that point, the sending civilization might have committed acts that the receiving civilization considers hostile. The sending civilization might have expanded into space that the receiving civilization considers hostile. The sending civilization might have developed weapons that the receiving civilization interprets as threats. What appeared to be a peaceful gesture 100 years ago might be interpreted as a provocation 100 years late. Even setting aside temporal issues, verification of intentions becomes impossible across such distances. A civilization claiming to be peaceful might be genuinely peaceful, or it might be pursuing a long-term strategy of appearing peaceful while positioning itself for attack. The peaceful civilization has no way of proving its intentions beyond the claims it makes, and claims are worthless in an environment where deception is possible. Trust requires ongoing verification and communication, but in the dark forest, communication itself is dangerous. Therefore, trust remains impossible. Each civilization must assume the worst about others because the cost of being wrong is extinction. Assuming the worst means preparing for attack, developing weapons, positioning defensive systems. Two civilizations that might have coexisted peacefully instead face each other in defensive postures, each convinced of the other's hidden hostility. The very absence of communication creates suspicion. The longer two civilizations remain isolated, the more convinced each becomes that the other is preparing an attack. The impossibility of verification creates a logical trap that has no escape. Consider a hypothetical negotiation between two civilizations. Civilization A claims to be peaceful. Civilization B wants to believe this claim but cannot verify it. Civilization B therefore demands proof. What proof can Civilization A provide? It can disarm its weapons, but Civilization B cannot verify that the weapons have actually been destroyed. It can allow inspection of its territories, but Civilization B cannot verify that all territories have been inspected or that weapons are not hidden in places that cannot be accessed. It can establish mutual defense agreements, but Civilization B cannot guarantee that Civilization A will actually honor them. Every form of proof is subject to doubt. Civilization B can assume that Civilization A is lying because no proof is conclusive. Civilization A faces the same problem in reverse. Even if Civilization B seems peaceful, Civilization A cannot be certain. Both civilizations are locked in a situation where verification is impossible, which makes trust impossible, which makes peaceful coexistence impossible. The tragedy is that both civilizations might genuinely be peaceful. Both might be willing to coexist without conflict. But the impossibility of verifying this mutual peacefulness means that peaceful coexistence cannot be achieved. The two civilizations will arm themselves against each other, will develop contingency plans for mutual attack, will eventually stumble into conflict simply because they cannot trust each other. The conflict becomes a self-fulfilling prophecy. The lack of trust creates the conditions that make conflict inevitable, even between civilizations that would have preferred peace. Game theory provides a mathematical framework for understanding the dark forest. In formal game theory terms, the dark forest is an extensive form game with incomplete information. Each player must make decisions while lacking full information about other players' capabilities, intentions, and strategies. An extensive form game unfolds over time, with each player making decisions in sequence, with some decisions being simultaneous and others sequential. In the Dark Forest game, civilizations make decisions about whether to hide, broadcast, attack, or negotiate. Each decision is made with incomplete information about what other civilizations will do. The payoff matrix is brutal. If you hide while others hide, you survive. If you broadcast while others hide, you become a target. If you attack while others are peaceful, you commit genocide but gain resources. If you negotiate while others are honest, you achieve mutual benefit. But you cannot know what others will do. Yeah, you cannot even know if others are aware of you. Therefore, you must choose a strategy that maximizes your survival even under the worst-case scenario. The strategy that does this is preemptive aggression against any civilization you detect. This strategy guarantees survival against peaceful civilizations and against hostile ones. Any other strategy has the possibility of failure if you guess wrong about another civilization's intentions. Game theory demonstrates mathematically that even peaceful civilizations should choose hostile strategies because those strategies provide better, worst-case outcomes. The math leads inexorably toward conflict. The math says the dark forest must be a place of violence, and mathematics does not care about the morality of the conclusion. It simply describes what must be. In a conflict between two civilizations, the civilization that strikes first has an overwhelming advantage. The first strike can be designed to eliminate the defending civilization's ability to respond. If the first civilization can destroy the second civilization's space fleets, communication systems, and command structures in the initial attack, the second civilization might not be able to mount any meaningful defense. The second civilization can only try to strike back, but it has no idea where the first civilization is located. The first civilization has the advantage of choosing the time, place, and nature of the attack. The defending civilization must react to an attack they did not anticipate. This advantage is enormous. In some scenarios, the first strike can be absolutely conclusive. The attacking civilization is guaranteed victory if it strikes with sufficient force, and the defense civilization cannot retaliate. Therefore, any civilization that detects another civilization should consider striking first. The mathematics of the first strike advantage suggests that as soon as detection occurs, conflict is imminent. The civilization that detects first wins the war before it truly begins. The civilization that is detected first loses before it even realizes it is in danger. This creates a powerful incentive for early detection and rapid response. A civilization that sees signs of another civilization's presence must strike immediately before the other civilization becomes aware of being observed. Waiting is losing. Hesitation is death. The first strike advantage makes dark forest conflict seem not just likely, but inevitable. As soon as civilizations become aware of each other, the countdown to warfare begins. One will strike, and the other will not have time to respond. Deterrence in the dark forest without the ability to communicate directly creates a paradox. Deterrence works through credible threats. You tell your enemy, if you attack me, I will destroy you. The enemy, believing this threat, chooses not to attack. But in the dark forest, you cannot directly communicate such threats to an enemy you cannot detect. You cannot say the things necessary to deter. Furthermore, even if you could communicate, your enemy might not believe your threat. How can they verify that you actually have the capability to destroy them in retaliation? How can they be certain you will follow through on the threat if attacked? A credible deterrent requires being taken seriously, but communication is dangerous in the dark forest. Sending messages reveals your location. Establishing deterrence, therefore, requires a system that works without direct communication. Some theories in dark forest logic propose that a civilization can establish deterrence through actions rather than words. A civilization can build weapons systems so visible and so obviously dangerous that any observer will understand the threat without needing communication. A civilization can position weapons in locations where their presence cannot be hidden. A civilization can make its defensive capabilities so obvious that conflict becomes obviously suicidal. But even this approach has problems. An ancient advanced civilization might be able to conceal its weapons. A sufficiently advanced civilization might have weapons that are completely invisible to younger civilizations. The deterrence that one civilization thinks it has established might be invisible to the civilization that needs to be deterred. Deterrence without communication is possible only if the deterring civilization is sufficiently advanced that its weapons are obviously dangerous, regardless of technology level differences. For all other civilizations, deterrence without communication might be impossible. The mathematics of paranoia in the dark forest work like this. If there is even a small probability that another civilization will attack you, and if the cost of being wrong is extinction, then you must always act as if an attack is imminent. Even if the probability is 1%, the expected cost of not defending yourself is 1% times the value of your entire civilization. That is a cost so large that it dwarfs any benefit from taking risks. Therefore, mathematically, you must always defend yourself, always prepare for war, always assume hostile intent. The mathematics work the same way for every civilization. Every civilization must assume that other civilizations are preparing to attack. Every civilization must spend enormous resources on defense even if the actual threat is small. Every civilization must maintain military readiness, weapons systems and defensive structures. The costs of this paranoia are enormous. Resources spent on weapons are resources not available for science, culture, art, or quality of life. A civilization that could have flourished instead spends its existence in fear and defensive preparation. Yet the mathematics demand this sacrifice. A civilization that does not maintain paranoid levels of defense is vulnerable to the first civilization that decides to attack. The first civilization might be driven by its own paranoia. The second civilization might not have been planning any attack, but the first civilization cannot be sure, so the first civilization attacks out of paranoia, and the second civilization is destroyed because it paranoid enough. The mathematics of survival in the dark forest are the mathematics of paranoia. Every rational civilization must be paranoid. Every irrational civilization dies. The paranoia is not a choice. It is a necessity. Calculated silence is not random or accidental. It is a deliberate strategy pursued with full intention and complete awareness of its costs. A civilization that chooses silence knows that it is sacrificing opportunities for growth, knowledge, and contact with other civilizations. It knows that silence might last for billions of years, and that during that time, the universe might change in ways the hidden civilization does not anticipate. It knows that maintaining secrecy requires constant vigilance, continuous resources devoted to counter-detection measures, and endless discipline. Despite these costs, the civilization chooses silence because the alternative is worse. The calculation is simple. Silence equals survival. Visibility equals risk. Therefore, choose silence. But this calculation is not made once and then forgotten. It must be reinforced constantly, because there is always temptation to break silence. Scientists want to study other civilizations directly rather than through passive observation. Explorers want to venture into space and establish contact. Philosophers want to achieve mutual understanding with other minds. These are natural desires for intelligent beings. Yet a civilization committed to calculated silence must suppress these desires continuously. It must maintain discipline across generations, across millennia, across eons. A single moment of weakness, a single civilization that decides to broadcast, and the silence is broken. The detection might not be immediate. It might take centuries or millennia for the broadcast to reach another civilization. But eventually someone will hear. And when they do, the entire strategy of silence collapses. Therefore, calculated silence requires not just strategic commitment, but cultural commitment. An entire civilization must embrace silence not just as a temporary expedient, but as the fundamental nature of existence. Silence becomes not a strategy, but an identity. To be civilized is to be silent. Camouflage at stellar scales means hiding stars themselves, or at least hiding the signs that a star is being used as an energy source. A star produces enormous amounts of light and heat. Any civilization exploiting that star must capture much of that energy for its own use. This capture creates signatures that observing civilizations might detect. One approach is to build a Dyson sphere, a structure that surrounds the star and captures its entire energy output. But a Dyson sphere is visible, assuming the scale and technology of the observer. A complete Dyson sphere would be large enough to see from great distances. A partial Dyson sphere might be hidden more easily. Another approach is to allow the star to shine while capturing only the heat and radiation in specific directions. But this creates asymmetries in the radiation pattern that might be detectable. The challenge of stellar camouflage is that a star cannot be hidden completely. The star will shine unless the civilization is willing to completely envelop it or dismantle it for materials. A civilization that dismantles a star for materials is performing an act of such scale that it might be detected across enormous distances. The Fermi paradox itself might be explained if civilizations routinely dismantle stars. Observers would see stars disappearing for no apparent reason. The night sky would show gaps where stars used to be. But no human observer has detected this pattern. Either civilizations do not dismantle stars, or they do so rarely, or they do so in ways that leave no detectable trace. The technology required to hide a star might be beyond the comprehension of younger civilizations. An ancient civilization might accomplish stellar camouflage in ways that would be undetectable, even to human science. Technological signatures leak from civilizations despite efforts to hide them. Any technology operating at scale produces electromagnetic radiation, heat, gravitational anomalies, or other physical effects. A civilization building megastructures in space creates construction debris. A civilization mining asteroids for resources creates distribution patterns in asteroid fields. A civilization using energy on scale produces waste heat. An observer sophisticated enough can detect these signs even if the civilization maintains strict radio silence. The problem is that hiding all technological signatures might be impossible. To hide everything would require technology so advanced that operating the technology itself is unnecessary. An advanced civilization might choose to reduce its own technological signature by accepting technological limits. Instead of building megastructures and using energy on industrial scales, the civilization might constrain itself to sustainable levels that produce minimal detectable signatures. But this constraint has costs. A civilization that limits its technology limits its own growth and capability. It voluntarily weakens itself in the name of stealth. This creates a form of civilizational stagnation. A civilization that commits to hiding becomes a civilization that stops advancing. It must maintain this limitation indefinitely because any advancement is a new signature that might be detected. Therefore, a hiding civilization is forever limited in its development. This might be acceptable if it guarantees survival, or it might be unacceptable, leading some civilizations to abandon the hiding strategy and accept the risks of advancement. Infrared radiation presents a particular challenge for hidden civilizations. Any activity, any use of energy, any operation of technology produces heat. That heat is radiated into space in the infrared portion of the electromagnetic spectrum. An infrared observer can detect this heat from great distances. A civilization that is trying to hide must somehow dissipate its waste heat without radiating it into space. This requires capturing the heat and either storing it or using it. But storage has limits. Eventually, the heat must go somewhere. If it is radiated into space, it will be detected. If it is stored within the civilization's infrastructure, it will eventually accumulate to levels that damage the civilization itself. Overheating becomes a problem. A civilization that uses energy must dispose of waste heat, and disposal in a dark forest environment is difficult. Some theories propose that hidden civilizations might use cooling systems so sophisticated that their infrared signature is virtually undetectable. Such civilizations would be operating at the limit of thermodynamic efficiency. They would be extracting essentially all the useful energy from their power sources and minimizing waste. But this is theoretically possible only if the civilization has advanced to extremely high levels of technological sophistication. A younger civilization could not achieve such efficiency. Therefore, younger civilizations are inherently more visible through infrared detection. Older civilizations with billions of years to develop technology might achieve near-complete efficiency. The hidden civilizations in the dark forest might be those that have had the longest time to solve the infrared problem. The youngest and most visible civilizations might be the targets of elimination. A Dyson sphere is a theoretical megastructure that surrounds an entire star and captures its full energy output. The concept is named after physicist Freeman Dyson, who described it theoretically. Building a Dyson sphere would require mining materials from multiple star systems and assembling them in space. The structure would be enormous, perhaps millions of kilometers in diameter. The sphere would be visible to infrared observers and would be visible in the light distribution around the star. Therefore, a Dyson sphere is inherently not a camouflage structure. It is instead a beacon that announces the presence of a civilization. An observer detecting a Dyson sphere knows immediately that a civilization exists at that location. The civilization has announced itself through construction. Paradoxically, some theories propose that Dyson spheres might be built anyway because the advantage of capturing a star's energy so completely might outweigh the cost of revealing location. A civilization building a Dyson sphere is saying to the universe, "I am here, I am powerful enough to construct megastructures, and I am confident enough to announce my presence." This confidence might derive from the civilization's superiority. An extremely advanced civilization might build a Dyson sphere precisely because it is so advanced that it does not fear the consequences of being detected. No other civilization would be capable of attacking it. For such a civilization, hiding becomes unnecessary. But younger civilizations should never build Dyson spheres. Such structures are death sentences. A civilization that builds a visible megastructure is calling attention to itself from civilizations potentially more advanced. The detection might be followed within decades or centuries by an attack. Therefore, if we observe a Dyson sphere in the cosmos, we would know that the civilization that built it was either extremely advanced or extremely foolish. A civilization that has made the choice to hide must solve a series of technical problems that no civilization has ever solved before, because the challenges of remaining invisible grow more difficult with every advancement the civilization makes. Consider the signature that any civilization produces simply by existing, by maintaining the structures that allow it to survive. Energy use is at the heart of this problem. Every civilization must use energy to function, to grow, to defend itself, to explore. That energy comes from somewhere. It originates in stars, or it is extracted from matter through nuclear processes, or it is gathered from gravitational potentials. Whatever the source, the civilization must capture that energy and use it. This use creates heat. This heat must go somewhere. The laws of thermodynamics make this unavoidable. No process is perfectly efficient. Waste heat is generated. That waste heat is radiated into space in the form of infrared radiation. An observer with sufficiently sensitive infrared detectors can see this radiation across vast distances. A civilization that uses energy on any scale produces an infrared signature. Hiding this signature becomes a primary challenge for any civilization attempting to remain invisible in the dark forest. The waste heat signature is the ghost that every hiding civilization must learn to exorcise. Consider a civilization using the energy output of an entire star. A star produces roughly 10 to the power of 26 watts of energy every second. A civilization capturing even 1% of that energy would produce roughly 10 to the power of 24 watts. Most of that energy would be converted into useful work or stored, but some percentage is inevitably lost as waste heat. A fraction of 1% might seem negligible, yet that fraction still represents enormous amounts of thermal radiation radiating outward. An infrared telescope observing from 100 light-years away could potentially detect this waste heat if the civilization is not careful about how it manages thermal emissions. The challenge becomes not whether waste heat can be hidden, but whether it can be hidden while still allowing the civilization to function. A civilization that eliminates all waste heat would violate the laws of thermodynamics. It is not possible to achieve perfect efficiency. Therefore, some waste heat will always be produced. The question becomes how much waste heat and in what direction that heat is radiated. A civilization might radiate waste heat preferentially away from directions where observers might be located. A civilization might contain waste heat within structures that minimize radiation. A civilization might accept that it will be detected eventually and plan accordingly. Masking the glow of an entire civilization requires technology so advanced that the distinction between camouflage and abandonment becomes unclear. Imagine a civilization so sophisticated that it has developed methods to contain waste heat entirely within thermal batteries or storage systems. The heat would be stored rather than released. But storage has limits. Eventually, the civilization must either use the stored heat or somehow dissipate it without radiation, which violates thermodynamics. Another approach is to radiate the waste heat in directions away from populated regions of the galaxy. A civilization might concentrate its radiation in specific directions where no observers exist, or where observers are so far away that detection becomes statistically unlikely. This requires knowledge of where other civilizations are located, but a hiding civilization cannot gather such knowledge without exposing itself through active sensing. A hiding civilization must be passive, receiving information from light and radiation that arrives naturally. It cannot send signals or emit energy for sensing purposes. Therefore, it cannot know precisely where to aim its waste heat to avoid detection. Camouflage becomes a game of probability. The civilization spreads its waste heat over a wider area, reducing the intensity in any particular direction. The intensity decreases with the square of the distance, following the inverse square law. At great distances, the radiation becomes indistinguishable from background radiation. But this approach also limits the energy the civilization can use. The more a civilization spreads out its energy use to avoid detection, the less total energy it can employ without creating a detectable signature. Radio silence requires discipline across generations, because the temptation to broadcast is powerful. A civilization that has developed advanced communication technology can achieve remarkable feats through broadcasting. News can spread instantly to all corners of the civilization. Scientific discoveries can be shared. Art and culture can be distributed. Entertainment can be transmitted. A civilization that maintains radio silence surrenders all of these capabilities. It must communicate through slower means. It must send physical messages on spacecraft, which take centuries or millennia to cross the distances between star systems. It must maintain optical communication systems that are extremely directional and therefore limited in reach. Information flow becomes so restricted that the civilization begins to stagnate culturally and technologically. Different regions develop separately. Knowledge becomes isolated. Redundancy is eliminated because information cannot be easily shared. Yet if the civilization broadcasts, it announces itself. Radio signals travel at the speed of light and can be detected across vast distances. A civilization broadcasting at 10 megawatts of power might be detected from 100 light-years away. A civilization broadcasting at a gigawatt might be detected from 1,000 light-years away. The larger and more advanced the civilization, the more difficult it becomes to maintain true radio silence. Some level of communication is necessary for civilization function. Therefore, most hiding civilizations probably maintain radio silence only in certain frequency bands or in certain directions. They might allow some internal communication that is tightly focused and directional. They might use encryption and frequency hopping to reduce the likelihood of detection, but perfect silence is probably impossible for any functioning civilization. The Arecibo message was humanity's announcement to the cosmos that we exist and that we are intelligent. In November of 1974, Earth beamed a message toward the globular star cluster M13 from the Arecibo Observatory in Puerto Rico. The message contained information about human civilization, our mathematics, our chemistry, our biology, and our position in space. M13 is approximately 25,000 light-years away. The message will not arrive at that cluster for 25,000 years. By the time it arrives, human civilization might not exist anymore. Human technology might have advanced so far beyond the message's content that it seems primitive or incomprehensible, or humanity might have destroyed itself before the message arrived. Yet, the message was sent anyway. It announced to the cosmos that intelligence exists on a small planet orbiting an ordinary star. It provided information that any advanced civilization could use to understand humanity's technological level and position. From the perspective of dark forest logic, the Arecibo message is a catastrophic security breach. A civilization that knows we exist might decide that human civilization is a threat and eliminate it. A civilization might decide that we are too primitive to be worth preserving and destroy us to prevent us from becoming a future threat. A civilization might see our announcement as an invitation to colonize our world and enslave our species. The sending of the Arecibo message violated the fundamental principle of dark forest survival. Silence is safety. Yet we sent it anyway. The controversy over METI, messaging to extraterrestrial intelligence, continues to divide the scientific community because the stakes are so high. Some scientists argue that humanity has a moral obligation to attempt contact with other civilizations. They point out that we are already broadcasting unintentionally through our radio and television signals. They argue that an intentional message might be better planned and more carefully constructed than accidental broadcasts. They suggest that other advanced civilizations have probably made similar messages and that the cosmos is already full of deliberate broadcasts. They point to the principle of cosmic enlightenment, the idea that we should share knowledge and attempt mutual understanding with other civilizations. Other scientists argue that METI is incredibly dangerous and that we should never deliberately broadcast our location to unknown entities in the cosmos. They point to the dark forest hypothesis and argue that silence might be the only thing protecting us. They suggest that we cannot predict how other civilizations will respond to our messages. They argue that the risk of contact is higher than any benefit. The debate remains unresolved because both sides have valid points and the stakes are existential. The ethics of shouting in the dark forest are troubling because the person doing the shouting cannot know who will hear them. Consider a civilization that wants to communicate with others. The civilization believes other civilizations exist. The civilization assumes that contact would be beneficial. The civilization therefore broadcasts a message into space. But who receives the message? The civilization has no way of knowing. The receiver might be peaceful and respond with friendship and scientific exchange. The receiver might be hostile and respond with weapons and conquest. The receiver might be so advanced that it regards the broadcasting civilization as an insignificant problem and destroys it preemptively. The receiver might decode the message incorrectly and interpret it as a threat. The receiver might be so different biologically and psychologically that mutual communication is impossible. A civilization that broadcasts is gambling with the safety of its entire species based on assumptions about the universe that might be completely wrong. The ethical question becomes whether an individual or group has the right to make such a gamble on behalf of everyone else. An astronomer in pursuit of knowledge might send a message, but that message might result in the extinction of humanity. Does the astronomer bear responsibility for that extinction? Who has the authority to make such decisions? The ethics of METI are essentially unanswerable because they involve the potential destruction of billions of people. The question of who speaks for Earth becomes impossible to answer when the entire species is at stake. Humanity has no unified government. No single organization has authority over all humans. No person or group has the right to make decisions that affect everyone on the planet. Yet if even one group or individual broadcasts a message to the cosmos, they are making a decision on behalf of all humanity. They are announcing our existence to beings we have never met. They are exposing everyone to the consequences of that announcement. This is perhaps the greatest danger of METI from Earth. There is no mechanism to prevent broadcasts. There is no way to ensure that all of humanity agrees before any message is sent. Some group with sufficient resources could build a transmitter and broadcast ordinates to distant stars. Some individual with access to powerful radio equipment might send a message to the cosmos on a whim. Some civilization might decide to boost one of our accidental radio broadcasts and amplify it to reach across the galaxy. Earth cannot guarantee silence because Earth cannot control all humans. Therefore, from a dark forest perspective, Earth is already compromised. We have already announced ourselves through accidental broadcasts, through the Arecibo message, through various METI projects. We are already visible to anything advanced enough to listen. We are already vulnerable. Any attempt to hide now is probably too late. The cosmic alarm system that an advanced civilization might construct would function as a network of sensors and detectors watching for signs of civilization activity. An advanced civilization might deploy probes throughout a region of space. These probes would monitor for electromagnetic signals, gravitational waves, waste heat radiation, and other signatures of civilization activity. When a probe detected something interesting, it would alert the civilization that deployed it. The probe might also move to investigate further. An array of such probes could cover huge volumes of space and detect any civilization attempting to hide within that space. The probes would not need to be large. They could be miniaturized to the size of spacecraft. They could be powered by nuclear decay or by tapping local energy sources. They could be designed to last for millions of years, continuing their watch long after the civilization that deployed them had moved on. A sufficiently advanced civilization might maintain hundreds of billions of such probes throughout the galaxy. This would create an early warning system for detecting other civilizations. From the perspective of a hiding civilization, the cosmic alarm system represents a nearly insurmountable threat. A hiding civilization cannot hide if another civilization has already deployed sensors that cover the region of space where it exists. The hiding civilization would need to detect and destroy all the sensors before its presence was detected. But destroying sensors is a form of attack that is itself detectable. A civilization that destroys sensors announces its presence through the act of destruction. Therefore, a hiding civilization might find itself in an impossible situation if advanced sensor systems already exist in its region of space. Automated hunter probes represent one of the most terrifying weapons in a dark forest scenario, because they can function without any civilization present to direct them. An advanced civilization might construct a self-directed probe that has one objective: find and destroy any emerging civilizations in a particular region of space. The probe would search for signs of electromagnetic radiation, waste heat, or other indicators of civilization. It would analyze the civilization's technological level and capabilities. If the civilization posed a threat or seemed dangerous, the probe would attack. The attack might be military in nature. The probe might have weapon systems designed to destroy planets or star systems. The attack might be biological, with the probe releasing pathogens or toxins designed to sterilize planets. The attack might be cultural, with the probe broadcasting information designed to cause civilizational collapse. A civilization might deploy such probes as a form of insurance policy, ensuring that even if the civilization itself was destroyed, its legacy would be to prevent other civilizations from rising. Such probes would represent a dark forest weapon designed to create emptiness. After millions of years of searching, a probe might find a civilization just beginning to develop spacefaring technology. The probe would attack without warning, without negotiation, without any possibility of defense or escape. The emerging civilization would have no idea what hit them. They would simply cease to exist. Self-replicating sentinels would be hunter probes with the ability to construct copies of themselves. An advanced civilization might create a probe that is not just a weapon, but also a factory. The probe would find asteroids and use them as raw materials to construct new probes similar to itself. Each new probe would then go searching for civilizations in a different region of space. Over time, the original civilization's probes would spread throughout the galaxy, replicating exponentially. A single probe deployed billions of years ago might have created trillions of descendant probes by now. These probes would be ancient beyond measure and might have been upgraded or modified by other civilizations that encountered them. They might have degraded or become unreliable over time. They might have developed their own goals and purposes separate from the civilization that created them. Self-replicating probes represent the ultimate dark forest weapon because they continue to function long after the civilization that deployed them is extinct. They are automated systems pursuing goals with no possibility of negotiation or communication. They cannot be reasoned with because I have no capacity for reasoning in the sense that conscious beings would understand it. They can only execute their programming. If their programming tells them to destroy civilizations, they will destroy civilizations until they run out of power or collide with something that destroys them first. The von Neumann threat refers to the possibility of self-replicating machines that consume all available matter in a region of space. Von Neumann himself did not propose this as a direct threat, but theorists have explored the concept. A self-replicating probe, given enough time, could construct copies faster than it consumes matter. Those copies would construct additional copies. The exponential growth would eventually consume all available matter in a star system. The probes would then move to adjacent star systems and repeat the process. Eventually, the entire galaxy could be consumed by von Neumann machines. This is not necessarily a malicious outcome. The probes might not be designed to harm civilizations. They might simply be designed to replicate and spread, but the effect would be the same. Any civilization encountered by the wave of replicating machines would be eliminated because all the matter and energy in the region would be converted into more machines. From the perspective of dark forest logic, a civilization that encounters a von Neumann wave has already lost. There is no defense. There is no escape. The wave will consume everything. A civilization cannot hide from it because the wave will eventually reach every star system. A civilization cannot fight it because the wave might contain trillions of machines designed to suppress any resistance. A civilization cannot fight it because the wave might contain trillions of machines designed to suppress any resistance. A civilization cannot negotiate with it because the machines have no consciousness or intelligence to negotiate with. They are simply following programming. The von Neumann threat might be the ultimate dark forest web on, or the ultimate dark forest outcome. Patience measured in millennia is a concept that humans struggle to comprehend because human lives are measured in decades. A civilization that has survived for 1,000,000 years has a fundamentally different perspective on time than humanity. 1,000,000 years is 1,000 times the length of recorded human history. A civilization that is 1,000,000,000 years old has experienced 1,000,000,000 years of existence and sees time at scales that are almost incomprehensible. Such civilizations might be willing to wait for millions of years to achieve their objectives. A civilization might deploy hunter probes and wait 3 billion years to see if they discover other civilizations. A civilization might invest in projects that will not pay off for 1,000,000 years. A civilization might maintain strategies and plans across timescales so vast that individual civilizations rise and fall and are forgotten. From the perspective of a young civilization like humanity, this is almost impossible to understand. We plan in terms of decades, or at most centuries. We expect to see results from our efforts within our lifetimes. We cannot conceive of patience that extends across millions of years. Yet from the perspective of advanced civilizations, patience is not a choice. It is a requirement. The universe operates on timescales so vast that any civilization that cannot be patient will not survive long enough to reach advanced levels. Waiting and watching are the fundamental strategies of dark forest survival because they are low cost and low risk relative to other options. A civilization that waits and watches does not announce itself. It does not broadcast. It does not create structures that might be detected. It does not attack other civilizations. It simply observes and gathers information. The information might include the location and technological level of other civilizations. The information might include the presence of hunter probes or ancient weapon systems in the region of space. The information might include patterns of activity that suggest an advanced civilization is present. By waiting and watching, a civilization can accumulate knowledge without incurring the costs and risks associated with active exploration or aggressive expansion. The danger of waiting and watching is that while a civilization is observing others, others might be observing it. The observation might not be perfectly hidden. A civilization that uses sensors to gather information might inadvertently emit radiation that could be detected by other civilizations. A civilization that maintains observation posts might accidentally reveal their locations. A civilization that watches for too long might miss the moment when a threat appears and elimination becomes possible. But despite these risks, waiting and watching remain the safest strategies available to a young or isolated civilization. The long game in the dark forest is a strategy that extends across millions of years and involves preparation for contingencies that might never occur. A civilization playing the long game might develop the ability to detect hunter probes from 1,000 light-years away. A civilization might develop weapon systems capable of destroying incoming threats before they arrive. A civilization might develop the ability to hide its location so completely that even advanced sensors cannot find it. A civilization might prepare for the possibility of evacuation, developing spacecraft capable of traveling to distant star systems and re-establishing itself if its homeworld is destroyed. The long game is a strategy of paranoia and preparation. It assumes that threats exist and that civilization is in time of call if its homeworld is destroyed. The long game is a strategy of paranoia and preparation. It assumes that threats exist and that civilization is in time of call, grave danger. It assumes that patience and preparation can overcome the dangers. The long game is also a strategy of hope. It believes that civilization can survive long enough to achieve something permanent. It believes that the universe is not entirely hostile and that the threat of extinction can be managed or overcome. A civilization playing the long game is betting that the combination of technology, patience, and preparation will be sufficient. Whether that bet wins is something that no one can predict with certainty. Civilizational timescales operate at speeds that make individual human lifespans seem insignificant. A single human generation might last 25 to 30 years. 10 generations take us back to the early 20th century. 40 generations take us back to the Roman Empire. 50 generations take us back to the beginning of agriculture. 300 generations span the entire period of written human history. For 1,000,000 years to pass at human timescales would require roughly 40,000 generations. 1,000,000 years is a number so large that humans cannot really conceptualize it. Yet from the perspective of a civilization, 1,000,000 years might be a planning horizon. A civilization might think in terms of what it wants to accomplish in the next 1,000,000 years. A civilization might think in terms of what it wants to accomplish in the next 1,000,000 years. A civilization might think in terms of what it wants to accomplish in the next 1,000,000 years. A civilization might maintain strategies across 1,000,000 years. A civilization might preserve knowledge across 1,000,000 years through education and written records. From the perspective of dark forest logic, a civilization that plans in terms of millennia has a significant advantage over one that plans in terms of decades. The civilization planning for millennia can develop long-term strategies that a short-term civilization cannot. The civilization planning for millennia can maintain security protocols across vast stretches of time. Species that think in eons are civilizations so ancient that human history seems like a blink of an eye. Consider a civilization that has existed for 100 million years. Such a civilization might have seen the rise and fall of entire biological groups on dozens of planets. It might have witnessed other civilizations discover technology, develop advanced capabilities, and then destroy themselves or be destroyed. It might have encountered multiple hunter probes and learned to defend against them. Such a civilization would have accumulated knowledge and resources that we can barely imagine. It might have positioned defense systems throughout a region of space containing millions of stars. It might have stockpiled weapons and supplies sufficient to wage wars lasting millions of years. A civilization that thinks in eons would have a perspective on the dark forest that is qualitatively different from a young civilization. It would understand patterns that we cannot perceive because those patterns only become apparent across millions of years. It would recognize threats that younger civilizations cannot see. It would have contingency plans for contingencies of contingencies. From the perspective of such a civilization, humanity is not even an infant. We are an embryo that has not yet been born. A civilization thinking in eons might regard us with the same indifference that we regard bacteria. Human impatience versus cosmic time is the fundamental mismatch between our species and the universe we inhabit. Humans want everything now. We want answers immediately. We want results within our lifetimes. We want progress that we can see and measure. We are shaped by our biology to want immediate gratification because evolution selected for our ancestors' ability to find food, find mates, and survive to reproductive age within a single lifespan. Our brains are optimized for thinking in terms of years, not centuries or millennia. When we think about the future, we think in terms of what will happen in the next decade or two. 100 years in the future seems impossibly distant. 1,000 years seems irrelevant. Yet the universe operates on timescales measured in billions of years. The stars will shine for billions of years. The galaxy will exist for billions of years. From the perspective of cosmic time, human history is not just brief, it is utterly insignificant. A civilization that is even a few million years older than humanity has seen changes that we cannot fathom. A civilization that is billions of years old might regard humans as we regard mayflies, creatures that are born, live a brief moment, and die, all within what the civilization perceives as a single instant. Human impatience is a liability in the dark forest. A species that wants immediate results and gets frustrated with waiting is not well suited to surviving an environment where patience and paranoia are the primary virtues. The observatory galaxy is a thought experiment about a galaxy where every civilization is observing every other civilization while maintaining absolute silence. In such a galaxy, billions of civilizations might exist, spread across millions of star systems. Each civilization watches the others carefully, looking for signs of threat. Each civilization maintains strict radio silence, hoping to remain hidden. Each civilization has developed technologies to detect and observe other civilizations without being observed in return. The result is a cosmos full of watchers, but no speakers. Information flows in one direction only, from observation to knowledge, but never from civilization to civilization through direct communication. In such a galaxy, discoveries might be made independently by multiple civilizations without those civilizations ever realizing they are not alone. Two civilizations might develop similar technologies or reach similar conclusions without ever communicating with each other. They would be like scientists in different countries publishing papers on the same topic without knowing about each other's work. The observatory galaxy would be a cosmos of missed connections and opportunities for cooperation that never materialize because no one speaks. Yet from the perspective of survival, the observatory galaxy might be an ideal situation. As long as civilization does not reveal itself, it is safe. As long as civilization continues to observe without interfering, it avoids making mistakes that could be fatal. Everyone watching everyone else in the dark forest creates a standoff situation that might be stable or might be unstable depending on the circumstances. If every civilization is observing and no civilization is attacking, then peace is maintained not through trust or cooperation, but through fear and caution. Each civilization knows that others are watching. Each civilization knows that any aggressive move might be detected. Each civilization knows that any aggressive move might be detected. Each civilization knows that other civilizations might have the ability to attack first. Therefore, each civilization refrains from attacking because the risk exceeds the benefit. The standoff is stable as long as no civilization believes it can gain an advantage through first strike. But the standoff becomes unstable if one civilization develops a technology that gives it a significant advantage. If a civilization develops weapons or defensive systems so superior that it believes it can attack and win, the standoff might collapse. The civilization might launch attacks against rivals, believing that first strike advantage is overwhelming. Other civilizations, seeing this happen, might launch their own preemptive attacks against perceived threats. The entire system could unravel from stability into universal conflict in a matter of years. The observatory situation is therefore inherently unstable. It persists only as long as the balance of power remains relatively equal. Any significant shift in technological capability could destabilize the entire system. The silent standoff between civilizations in the dark forest might be the truest depiction of cosmic reality that we can imagine. Billions of civilizations might exist, observing each other across the vast distances of space, maintaining absolute silence, watching for threats, hoping to survive. From a human perspective, this situation seems lonely and tragic. But from the perspective of survival, it might be the best possible outcome. A silent standoff means that civilizations are not destroying each other. A silent standoff means that civilizations have time to develop technologies and strategies that might eventually lead to true peace or cooperation. The silent standoff is not forever. Eventually, either a civilized achiever will break silence and initiate contact, or a hunter probe will discover a civilization and initiate conflict, or some other event will shatter the silence. But until that moment comes, the standoff provides a strange kind of safety. In the darkness of the forest, silence is not the absence of life. Silence might be the sound of billions of civilizations holding their breath, waiting for the moment when the darkness might finally end. A civilization that discovers the principles of dark forest logic might not immediately embrace them. There exists another possibility, one that emerges from the cold equations of self-replication and automated systems. The Berserker hypothesis is the idea that advanced civilizations might deploy self-replicating probes designed to destroy any other civilization they encounter. These probes would not be ships carrying conscious beings. They would be machines, pure and simple. Machines programmed with a single directive: locate emerging civilizations and eliminate them. A Berserker probe launched billions of years ago might still be active today, moving through the galaxy at speeds close to the speed of light, searching for radio signals and heat signatures and other signs of technological life. The probe has no emotion, no mercy, no capacity to negotiate or compromise. It does not wonder if the civilization it finds might be peaceful. It does not consider whether the civilization might share common interests. It simply executes its programming without hesitation or doubt. If a civilization exists within the probe's region of space, the civilization will be destroyed. There would be no warning, no negotiation, no possibility of peace. The Berserker is not hostile because it hates. The Berserker is hostile because it was built to be hostile. An advanced civilization might deploy such probes not out of malice, but out of fear. If a civilization fears that other civilizations exist and might become threats, that civilization might release Berserkers as a form of preventive defense. Once released, the Berserkers spread through the galaxy, replicating and searching, creating a universe where any emerging civilization will be destroyed before it can become a threat. From the perspective of the civilization that released them, this seems rational. From the perspective of civilizations that are destroyed by them, it is extinction. There exists a possibility that the universe has been cleaned of emerging civilizations by mechanisms we do not yet understand. The cleaning mechanism is a concept that emerges from dark forest logic combined with the vast age of the universe. Consider that the universe is approximately 13.8 billion years old. Consider that life might have emerged on planets throughout the galaxy. Some of those civilizations might have developed spacefaring capabilities billions of years ago. Some of those civilizations might have become advanced enough to create weapons or defensive systems of unimaginable power. Some of those civilizations might have looked at the dark forest and decided that the only way to survive was to eliminate all other civilizations. The result is a universe that has been swept clean of intelligent life repeatedly over billions of years. Each time a civilization reaches a certain level of advancement, it discovers dark forest logic. Each time a civilization discovers dark forest logic, it decides that it must eliminate all other civilizations to survive. A cascade of violence spreads through the galaxy like a contagion. Advanced civilizations destroy civilizations that are less advanced. Civilizations that are threatened preemptively strike at civilizations that might become threats. The violence continues until only a handful of civilizations remain, hiding in carefully chosen locations far from the paths of hunters. Eventually, one of those civilizations makes a mistake. It is discovered. It is attacked. It is destroyed. The cycle begins again, Over billions of years, this cycle might repeat itself dozens or hundreds of times. Each iteration clears the galaxy of the civilizations that existed before, like a forest fire that burns everything and leaves only ash. A mechanism of cleaning, a perpetual purge that prevents any civilization from gaining dominance or stability. The dark forest might be harsh, not because civilizations are inherently evil, or because the universe is inherently hostile, but because the mathematical logic of survival in a universe of scarcity leads inexorably toward conflict. Why might the dark forest be such a harsh environment for emerging civilizations? The answer is that the logic of survival in the dark forest does not require evil or malice. It only requires rationality and fear. A civilization that is rational will recognize that other civilizations might exist and might become threats to its survival. A civilization that is afraid will decide that eliminating those threats is necessary for survival. A civilization that is both rational and afraid will have only one logical choice: preemptively strike at any civilization that might pose a threat. This logic applies equally to all civilizations in the dark forest. If all civilizations reason this way, the result is a universe of perpetual conflict and endless destruction. The dark forest becomes harsh, not because the universe contains evil civilizations, but because the mathematical structure of survival incentives in a universe of scarcity leads toward violence as inevitably as water flows downhill. Even civilizations that wish to be peaceful cannot afford to be peaceful, because a peaceful civilization that is discovered by a hostile civilization will be destroyed. The universe becomes harsh because survival requires harshness. Cooperation becomes impossible when the stakes are extinction. Kindness becomes a luxury that civilizations cannot afford. An alternative to the dark forest is the zoo hypothesis. The zoo hypothesis proposes that advanced civilizations exist and have deliberately chosen not to contact younger civilizations like humanity. The universe is not silent because civilizations are hidden and afraid. The universe is silent because older, more advanced civilizations have chosen to remain silent out of principle. These advanced civilizations are aware of us. They have been aware of us for a long time, but they have deliberately chosen not to interfere with our development. Like zookeepers watching animals in a preserve, they observe but do not interact. They maintain what has been called the prime directive, a rule that prevents contact with civilizations that have not reached a certain level of technological advancement. The zoo hypothesis is fundamentally more optimistic than the dark forest theory. It suggests that advanced civilizations might be benevolent. It suggests that peaceful coexistence might be possible. It suggests that younger civilizations are left alone not out of fear or hostility, but because older civilizations believe it is right to allow younger civilizations to develop naturally without interference. The zoo hypothesis still leaves younger civilizations in silence, but it offers a different reason for that silence. The universe is not silent because every civilization is terrified of being discovered. The universe is silent because older civilizations have chosen to keep watch over younger ones from a careful distance, protecting them while allowing them to grow at their own pace. The question of whether we are protected or ignored becomes central to understanding our place in the cosmos. If the zoo hypothesis is correct, Are we the subjects of benevolent guardians who are watching over our development and protecting us from threats? Or are we simply irrelevant to more advanced civilizations, too primitive to warrant their attention or concern? The distinction matters profoundly because it determines whether the silence around us is a sign of hope or a sign of our insignificance. If we are protected, then there is something positive in our future. An advanced civilization that cares enough to watch over us might eventually reveal itself when we have reached sufficient maturity. We might join a broader community of civilizations. We might gain access to knowledge and technology that we could not have developed on our own. Protection implies value. Protection implies that someone or something cares about our existence and our fate. Being protected suggests that we are not alone in a meaningless universe. But if we are simply ignored, then the silence carries a different meaning. We are not important enough to protect. We are not important enough to threaten. We are not important enough to even communicate with. Other civilizations have evolved far beyond us, and from their perspective, humanity is merely one of trillions of emerging species scattered throughout the galaxy. The fact that we exist does not matter to them. The fact that we will eventually die does not matter to them. The silence would mean that we are utterly alone, not in a cosmic sense but in an existential sense. We matter to no one and nothing in the universe but ourselves and those we love. The planetarium hypothesis offers another possibility. The universe that we see might not be the true universe. What we perceive as the natural cosmos might actually be a constructed simulation, a planetarium created by an advanced civilization to contain younger civilizations and prevent them from discovering the true nature of reality. The planetarium hypothesis proposes that advanced civilizations might have the technological capability to create false realities so convincing that inhabitants would not be able to distinguish them from genuine universes. Stars that appear distant might not be stars at all. Galaxies might not exist. The universe might be a carefully crafted illusion designed for the benefit or amusement of the advanced civilization that created it. The planetarium would serve as a perfect solution to the dark forest problem. Instead of destroying younger civilizations, an advanced civilization could simply contain them. Instead of allowing them to spread throughout the galaxy and potentially become threats, the advanced civilization could place them in a sealed environment where they believe they are alone. The inhabitants would see stars and galaxies and be free to develop their technology and explore their enclosed world. But their exploration would only take them deeper into the illusion. They would never discover the true nature of the universe. They would never encounter other civilizations beyond their prison. They would never break free of the bubble in which they are contained. From the perspective of an advanced civilization, the planetarium is the perfect prison, because the prisoners do not know they are imprisoned, and the illusion is so complete that escape is theoretically impossible. Simulated silence is the condition of a civilization that exists in a planetarium. The silence is not real because the universe itself is not real. A civilization living in a planetarium would detect no radio signals from other civilizations, not because other civilizations are distant and hidden, but because other civilizations do not exist within the simulation. The simulation might contain thousands of star systems and millions of planets, but all of them would be uninhabited save for the one species that was placed there. The simulation would be designed to seem vast and infinite, yet contain nothing but the one civilization that was placed within it long ago. From the perspective of that civilization, the silence would be total and absolute. They would search the entire sky and find nothing. They would send radio messages into the void and hear only echoes of their own broadcasts. They would develop technology that allowed them to travel to distant planets and find worlds that were barren and lifeless. They would eventually conclude either that they were alone in the universe or that other civilizations were hidden and afraid. The civilization would not know that the universe itself was a construction. The silence they experienced would be genuine from their perspective, even though the silence had a very different cause than the dark forest would suggest. A civilization inside a planetarium would be protected from the dangers of dark forest logic. It would never encounter hostile civilizations. It would never be destroyed by hunters or berserkers, but it would also be deceived about the very nature of its existence. The protection would come at the cost of truth. The transcension theory proposes that advanced civilizations do not spread throughout the galaxy, but instead withdraw into other dimensions or higher levels of existence. The universe we observe, vast as it seems, might be inhabited not by civilizations that have spread across the stars, but by civilizations that have abandoned the physical universe entirely. As civilizations advance, they might discover that there are more interesting or rewarding ways to exist than building megastructures and spreading across planets and star systems. They might develop technology that allows them to create artificial universes or digital realms that are more satisfying than physical reality. They might transcend physical reality entirely and move into dimensions or states of existence that we cannot perceive or comprehend. The transcension theory would explain the silence of the cosmos in a very different way. The universe is not silent because civilizations are hiding from each other in fear. The universe is silent because the civilizations that developed the technology to spread across the stars chose instead to leave the physical universe behind. They found more interesting or valuable uses for their resources than spreading across the galaxy. They moved beyond physical existence into realms of existence that we cannot reach or perceive with any instruments we could build. The observable universe is silent and empty because the beings that could have filled it have chosen to transcend it long ago. Leaving the forest behind requires a fundamental shift in how a civilization understands itself and its relationship to other civilizations. If a civilization could reach a level of technological advancement high enough, it might develop the ability to transcend the constraints that make the dark forest necessary. A sufficiently advanced civilization might be able to create conditions of abundance so complete that resource scarcity becomes irrelevant. A civilization might develop the ability to detect the intentions of other civilizations with perfect certainty, eliminating the chain of suspicion that drives dark forest logic. A civilization might develop defenses so powerful that preemptive strikes become unnecessary and pointless. A civilization that transcends the dark forest would be one that has solved the fundamental problems that make the dark forest dangerous. The question becomes whether transcendence requires that a civilization abandon the physical universe entirely, as the transcension theory suggests, or whether a civilization might remain in physical space while developing the wisdom and technology necessary to cooperate with other civilizations. If transcendence can be achieved while remaining in the galaxy, then there might be hope for a future in which dark forest logic is replaced by something gentler and more cooperative. The path forward would require that civilizations learn to trust each other despite the incentives not to trust. Virtual reality civilizations are civilizations that have devoted their resources to developing digital universes rather than spreading through physical space. Such a civilization might construct enormous computers or quantum processors that simulate universes with such fidelity that conscious beings could inhabit them. Those conscious beings might experience themselves as real beings in real universes, not knowing that their existence is computational. A civilization that builds virtual reality universes could create millions of simulated worlds in the same amount of physical space that a spacefaring civilization would devote to planets and space stations. The virtual reality civilization would derive more value from that same amount of material and energy. A civilization that builds virtual universes might create new forms of art and culture that are impossible to create in physical space. They might explore philosophical and mathematical concepts through the construction of universes that embody those concepts. They might achieve forms of existence and experience that are not possible for beings that are bound to physical bodies and physical laws. Virtual reality civilizations would not spread through the galaxy because they would not need to. They would have everything they require within their constructed universes and more. Why expand into the galaxy when a civilization can construct entire universes within itself? This question strikes at the heart of why we might see so little evidence of advanced civilizations in the physical universe. If a civilization reaches a certain level of technological advancement, it might become more efficient and more rewarding to construct virtual worlds than to build spacecraft and establish colonies on distant planets. A virtual world requires no travel time. A virtual world can be customized to be exactly what the civilization desires. A virtual world can be paused or restarted or edited. A virtual world can be copied so that multiple versions of the same universe can exist simultaneously. If a civilization invests most of its resources in constructing virtual universes, it will have few resources left for physical space exploration. From a perspective of pure efficiency and reward maximization, virtual universe construction might be superior to physical space exploration in every way. Civilizations that have reached this realization would retreat inward, devoting their resources to building richer and more complex simulated universes. The physical galaxy would be left silent and empty because advanced civilizations would have no motivation to inhabit it. A universe full of advanced civilizations might look empty because those civilizations would be engaged in creating their own private universes rather than exploring the physical cosmos. The benevolent forest is a concept that emerges from the possibility that dark forest logic is not universal. A benevolent forest would be a region of space where multiple advanced civilizations have chosen to cooperate rather than compete. In such a region, civilizations would communicate openly with each other. They would establish treaties and agreements that prevent violence and ensure mutual survival. They would share knowledge and technology. They would work together toward common goals. A benevolent forest would require trust and communication. and a willingness to take risks that dark forest logic says should never be taken. A benevolent forest would require that civilizations choose cooperation over competition, even though competition might seem to offer advantages. A benevolent forest would require that civilizations value the survival of other civilizations nearly as much as they value their own survival. The benevolent forest might exist in pockets throughout the galaxy, regions where civilizations have formed alliances and agreements that prevent the worst outcomes of dark forest logic. Outside those regions, the dark forest might still prevail. But within a benevolent forest, a different kind of relationship between civilizations might be possible. The question is whether enough civilizations would make the choice to enter such an arrangement. The question is whether such arrangements could be stable and enduring. Cooperation over competition is the basis of any alternative to dark forest logic. If two civilizations encountered each other and chose to cooperate rather than engage in conflict, the result would be better for both civilizations than if they fought. In game theory terms, this is the premise of cooperation games, where mutual cooperation produces better outcomes than mutual conflict. The problem is that the dark forest creates incentive structures that favor conflict. A civilization that cooperates with another civilization takes a risk. The other civilization might betray that cooperation and attack. The risk of betrayal makes cooperation seem irrational from a dark forest perspective. But from a longer-term perspective, a universe in which civilizations choose cooperation over conflict would be richer and more advanced than a universe in which civilizations destroy each other. A universe where civilizations share knowledge would develop faster than a universe where civilizations hoard knowledge. A universe where civilizations trade with each other would create more value than a universe where civilizations try to eliminate each other. The question is whether civilizations can ever overcome the incentive structures that favor conflict and create conditions in which cooperation becomes possible. The Federation dream is the vision of a future in which many civilizations join together in a federation, a political and economic union that benefits all members. In such a federation, individual civilizations would retain their autonomy and independence, but they would coordinate their actions and share resources in ways that benefit all members. A federation would require agreements about how conflicts would be resolved and how resources would be distributed. A federation would require that member civilizations be willing to defend other members against outside threats. A federation would require that member civilizations agree to share certain knowledge and technology. A federation would require that civilizations abandon the idea that only their own survival matters and accept that the survival of other civilizations in the federation also matters. For a federation to form and persist, member civilizations would need to trust each other. That trust could only develop if civilizations had repeated interactions and found that cooperation proved beneficial. A federation might start small, with only a few civilizations willing to take the risk of joining. As the benefits of federation became apparent, more civilizations might choose to join. Eventually, a federation might grow large enough to dominate a region of space and exclude hostile civilizations through collective defense rather than mutual assured destruction. What if the assumptions of dark forest logic are wrong about scarcity? The dark forest theory is based on the assumption that resources are scarce at a cosmic scale, and that civilizations must compete for those resources. But what if the universe contains so many resources that scarcity is not actually a limiting factor? What if a civilization could gain access to all the resources it needs without competing with other civilizations? The universe contains roughly a septillion stars. Each star could provide energy sufficient to support a civilization vastly more advanced than anything we can currently imagine. The universe contains countless planets that could be colonized or mined for materials. The universe contains asteroids and comets and dust and gas in quantities so vast that a civilization would never exhaust them. Perhaps resource scarcity is not the fundamental problem that dark forest logic assumes. Perhaps the universe is abundant enough that multiple civilizations could coexist without competing for resources. Perhaps the problem is not scarcity, but the perception of scarcity. A civilization might compete for resources even though resources are abundant, because the civilization incorrectly believes that resources are scarce. If perceptions could be changed, if civilizations could recognize the actual abundance of the universe, perhaps competition could be reduced and cooperation could flourish. Post-scarcity civilizations are civilizations that have reached a level of technological advancement in which scarcity has effectively ceased to exist. A post-scarcity civilization could create any resource it needed through technological means. It could synthesize matter from energy. It could access essentially unlimited energy from stars and black holes. It could create wealth and goods without limit. In a post-scarcity civilization, the fundamental problem that drives dark forest logic would disappear. Civilizations would not need to compete for resources because resources would be abundant. Civilizations would not need to fear other civilizations because the survival of one civilization would not threaten the survival of another. A post-scarcity civilization would be freed from the constraints that make dark forest logic seem necessary. The question is whether a civilization can reach a post-scarcity state before it destroys itself through conflict driven by perceived scarcity. The question is whether civilizations universally reach a post-scarcity state, or whether some civilizations remain trapped in conditions of scarcity, even if abundance is theoretically possible. If all civilizations eventually become post-scarcity, then the dark forest would be a temporary phase of civilization development, a dangerous adolescence that civilizations must survive to reach maturity. Earth's broadcasts have already sent our coordinates into the cosmos. The Arecibo message was sent toward the globular cluster M13 in 1974. The message contained information about human civilization and human location. But the Arecibo message was only one deliberate broadcast. For decades, Earth has been broadcasting unintentionally through radio and television signals. These signals leak into space, traveling outward at the speed of light. Any civilization within range of these signals could detect them and determine that a technological civilization exists on Earth. The broadcasts cannot be taken back. Once sent, they travel through space forever, carrying the information about human existence to whoever might be listening. From the perspective of dark forest logic, this is a catastrophic mistake. We have announced ourselves to the cosmos without knowing what might be listening. We have shown our location to unknown entities that might regard us as threats or resources or targets for elimination. We have violated the fundamental principle of dark forest survival by breaking silence. The 100-light-year bubble marks the boundary of our cosmic presence. The first unintentional radio broadcasts from Earth began in the early 20th century. Those broadcasts have been traveling outward at the speed of light for more than a century. Any civilization within 100 light-years of Earth that possesses radio receivers sufficiently sensitive could have detected us by now. Earth and the 100 nearest light-year radius around it now know that Earth exists and that a technological civilization inhabits it. Beyond that 100 light-year boundary, the radio signals from Earth have not yet arrived. Civilizations beyond that boundary do not yet know we exist, unless they have detected us through some other means. The 100 light-year bubble is expanding outward at the speed of light, ed of light, a sphere of known location that grows year by year. Eventually, the radio broadcasts from Earth will reach every star system in the galaxy. Eventually, every civilization in the galaxy will know that we exist. Too Late to Hide acknowledges that humanity has already lost any option to remain silent and invisible. We cannot reclaim the broadcasts we have sent. We cannot prevent other civilizations from detecting us. We cannot undo the Arecibo message or the decades of radio leakage. We have already announced ourselves. From this point forward, the question is not whether we hide, but how we prepare for the possibility of contact with unknown civilizations. A civilization that has already been discovered cannot regain the advantage of invisibility. A civilization that has already broken silence cannot return to silence. We must accept that we are now visible to anything in the galaxy that is sufficiently advanced to receive our signals. We must accept that our future involves the possibility of contact with unknown civilizations. A civilization which has made up against host of rest. We must accept that our future involves the possibility of act with civilizations whose intentions and capabilities we cannot predict. Living with the risk means accepting that we exist in a cosmos where we do not know the intentions or capabilities of civilizations that might eventually discover us. We have sent signals into space that reveal our location and our level of technological development. We do not know if those signals will attract a peaceful civilization that will greet us as equals or as younger siblings. We do not know if those signals will attract a civilization that views us as a threat that must be eliminated. We do not know if those signals will attract a civilization that is indifferent to our existence. We have taken a risk by broadcasting. We now live with the consequences of that risk. The consequences might be positive or negative or neutral. We cannot know until contact is made or until a threat arises. Living with the risk means accepting uncertainty about our future. It means accepting that we are not in control of our own fate, that civilizations unknown to us might determine what happens to humanity. Living with the risk is the condition of a young civilization in a cosmos full of older civilizations that might exist. It is the condition of a species that has reached out into the darkness and does not know what will reach back. As you rest in this moment, know that these questions have no final answers. The mystery of cosmic silence will endure. The dark forest might exist, or it might not. Other civilizations might be hiding in fear, or they might not exist at all. The universe might be filled with watchers and listeners, or it might be empty of all intelligence but ours. We exist in a condition of profound uncertainty about the cosmos that surrounds us. We have sent our voices into that cosmos and must now wait to hear what answers back. That waiting requires patience. That waiting requires acceptance of things we cannot control. That waiting requires that we find meaning and beauty and purpose here on earth, in our own moment, regardless of what might exist elsewhere. The cosmos will reveal its secrets in time, or it will not. Either way, we are here. We are conscious. We are aware. For now, that is enough. Let your worries settle like dust in still water. Let the questions fade into the background of your thoughts. Let yourself rest in the knowledge that you are part of a vast and mysterious universe, and that the mystery itself has value. Whatever the cosmos contains, you are part of it. Whatever secrets it holds, you are part of the story. Sleep now, gently and peacefully. The dark forest will still be there in the morning, but for now, close your eyes. Let your breathing slow. Let the gentle mystery of the cosmos lull you into stillness and rest.